Hello everyone, I again welcome you all in the video series of Raspberry Pi. From today's lecture, we will start the programming aspects of the Raspberry Pi using Python. So, today we will do programming of LED blinking. Here we will connect the LED with our Raspberry Pi, and using Python we program to on and off our LED that is connected with the Raspberry Pi using Python. Okay, so let's start. So before going to the programming aspect, means the hands-on, we will see the pin configuration and the hardware structure of the Raspberry Pi. I have already explained you the hardware structure of the Raspberry Pi in the previous video. So there is a very important part in the Raspberry Pi. Here you can see at the right side of this figure, here you can see there are several pins that are embedded in the Raspberry Pi. So these pins are basically known as a GPIO pin. GPIO pin. That means general purpose input output pins. Okay. There are 40 pins that are available on the Raspberry Pi, and through these pins we can connect different types of sensors. Like I want to send the temperature or the humidity or some environmental condition, as I want to give some output to the sensor, okay, some instruction to the sensor. So whatever the sensor that are connected to the Raspberry Pi for the input output operation, that must be connected through this GPIO pin. Okay. Even we can connect the Bluetooth, we can connect the Wi-Fi, we can connect the external memory also, apart from the sensor, with this GPIO pin. Okay. So in the right side of the figure you can see the pin configuration of the Raspberry Pi. Here you can see there are 40 pins that are available on the Raspberry Pi. Okay. So from pin number 1 to pin number 40, and each and every pin of the Raspberry Pi have certain functions or the operations. So in the next slide, here we can see we will see what are the functions, what are the operations of each and every pins of this Raspberry Pi. Okay. So here you can see it is a 40 pin configuration, means there are 40 pins that are available on the Raspberry Pi chip. Okay. Here we have two types of power supply, that is to the sensors, means whatever the sensor that we are connected, they need some power to operate obviously. So there are two types of power supply is available on our Raspberry Pi kit, 3.3 volt supply and 5 volt supply. Okay. So there are certain sensors which support 3.3 voltage of supply. There are certain sensors that are connected with a Raspberry Pi supports 5 voltage of power supply. So whatever their need, the configuration is already mentioned on the sensor, that whether it needs a 3.3 voltage of supply or 5 voltage of supply. So we can give the power supply to the sensor using these these two types of power supply. So here you can see pin number 2 have a 5 voltage of power supply. Pin number 4 is also 5 voltage of power supply, and pin number 1 is 3.3 voltage of power supply. Pin number 17, 3.3 voltage of power supply. So here There are two pins, pin number 1 and pin number 17 are used for 3.3 voltage of power supply, and pin number 2 and 4 for 5 voltage. Okay. So every sensor that we connect to our Raspberry Pi, we must give the power supply with the 3.3 or 5 voltage. Okay. There are certain ground pins that are available on our in GPIO pin configuration. Here you can see pin number 6, 9, pin number 14, 20, pin number 25, pin number 30, 34 and 39. So these are the ground pins, and these are used to obviously to complete the circuits. We obviously need the ground pins. Okay. Third is reserved. So here you can see pin number 27 and 28. Yeah, pin number 27 and pin number 28. These are the reserved pins. So these pins are used to connect the external memory. So here you can see we have written here in reserved pin we cannot connect any input or output sensor with the reserved pins. These are used to connect external memory and obviously to store the data. So through these pins, pin number 27 and pin number 28, we can connect the external memory to store the data. Okay. Now the most important is the GPIO pin, that is known as general purpose input output pin. So here you can see there are several GPIO pins are available. For example, pin number 3, pin number 5, pin number 7, pin number 11 and so on. Okay, so there are several pins that are used for the general purpose input output. So whatever the sensors that are connected to the Raspberry Pi, whether we can get the input from these pins or we can give output through these pins to the sensors, to the sensor devices. Okay, for example, let we are sensing some data from the temperature sensor, so we will connect the temperature sensor to any of the GPIO pin. No problem, any of the GPIO pin. You can choose, for example, if you are using the ground pin, you can connect any ground pin. If you are using GPIO pin, you can connect pin number 2, pin number 3, pin number 4, GPIO pin number 17, 27. Any GPIO pin you can connect it. No problem. Okay. So whenever we are reading some temperature or some environmental condition through the sensors, so we must connect the data lines of that sensor to the GPIO pin. Through these data lines we can take the input, the measurement, the value that has been sensed by the sensor node through this GPIO pin into a Raspberry Pi, and also the Raspberry Pi also can give command to the sensor nodes through these GPIO pins. So we have to connect the data pin or the data line of the sensor through this GPIO pins. Okay, clear? So obviously we can give the command in on and off and 0 and 1, obviously digital form. So we are giving 1 true, that means we are giving this is the positive command given to the node. For example, if we are performing the LED blinking program, in that case we can give 1 to on the LED, we can give 0 to off the LED. Okay, so we can give the command in the form of true and false, 0 and 1, and also we can take the output or sense the output from the sensor in the form of digital. So obviously, as we know that the sensors only sense the devices that are connected to the Raspberry Pi will sensing some data in analog form. So we have to connect we have to convert it first into the digital form so that the Raspberry Pi can understand it, whatever we are sensing. Okay. Now we will talk about some other pins that are here. You can see in GPIO pins we have I2C connection, we have SPIO connections also. So what it means basically, So I2C is basically known as the inter-integrated communication. Basically, I2C and SPI are the communication protocols which the Raspberry Pi supports. So there are various types of sensors. Some sensors support I2C connection and some of the sensors connect SPIO connection. Okay. So whenever we connect those sensors which support the I2C connection, that is inter-integrated communication, uh, in that way we will use the GPIO pin, for example GPIO 2 or GPIO 3. Okay, and when we use SPIO connection, in that case we will use GPIO pin 10, GPIO pin 9, GPIO pin 11. Okay, so depending on the type of the sensor, we can use the different communication models, communication protocols to connect it. Okay, so these are the communication interface to transfer data between sensor and the Raspberry Pi module. Okay, there are certain pins that are pin number 8 and 9. You can see here are the UART pin that are known as Universal Asynchronous Receiver and Transmitter. So those here, these pins are used to connect those devices which are having TX and RX pins. That is known as transmitter and obviously the receiver pins. So for example, let me I want to connect the Bluetooth, or either we are connect to the Wi-Fi because these are having the TX and RX pin. In that case, we will use UART pin. So here you can see pin number 8 and pin number 10, that are UART pins. So these pins are used for connecting the universal asynchronous receiver transmitter. Okay. Now we come on the circuit diagram of the LED blinking. So I will show you physically this connection on the breadboard. So what basically to perform the LED programming, what the components that we need. Okay, the first component that we need the our Raspberry Pi kit, Raspberry Pi module. Okay, so firstly, obviously we need a Raspberry Pi module. Obviously, to give the power, we need a power cable, a simple charger cable that you use to charge your mobile. Obviously, to get the output, to see the to program this Raspberry Pi, we need a monitor, and to give the command, obviously we need a keyboard, and we have to connect it. So I will use in the previous video I've already shown you that I will use VNC. Okay, so I will use my laptop display as the display of the Raspberry Pi. I will use my laptop's keyboard for the input command, for giving the input to the Raspberry Pi. So I will do not use any other monitor or any other keyboard. I will use my own laptop monitor and keyboard. Okay, so the first we need this. Okay, now apart from this, we need a breadboard. We need a breadboard. The size of the breadboard may vary. I will use a small breadboard, and obviously all of you know the breadboard. Breadboard are used for designing the circuits. Okay, you can purchase online or from your local market also. It is available. Now here we will use some connectors, obviously the wires. So I will use male to female wire. Okay, to connect it, I have several wires. You can also purchase it, and obviously these are the LED lights. So I am having multiple LED lights. So these are the connections. Here you can see that we have connected. Also in this figure, a resistor is also shown here. Basically, this is a resistor of 220 ohm, and this resistor is used to restrict the power, that is voltage that is incoming in the LED, that will stop the basically this resistor are used to stop the extra current or the extra voltage that are going to the LEDs, and if the voltage is high, in that case the LED light can be damaged. So in that way we use the resistors. If we are not using the resistors, no problem. If you are having the controlled voltage, in that case we can leave this resistor. So in this case I am using 220 ohm of resistor. Okay. Now so here you can see we have in the LED we have two points, positive and negative. So the point, long wire point in the LED is showing the positive, and the small one is showing the negative one. So here you can see from the we have inserted that LED on the breadboard and connected the positive point to the GPIO pin, GPI to the board pin 3, that is the GPIO pin number 2, and we have connected the negative terminal of the LED light to the pin number 6, that is the ground. Okay. Now this is the circuit diagram. Now, if we talk about the programming, so I will show you physically in this video. I will show you the connections of this LED blinking program. Okay, now we come to the programming part of the LED blinking. So what we need in the step 1, we can see we are importing. First of all, we have to import the library of the Raspberry Pi, GPIO, and the time library also, because if you are giving the commands to if you are giving the GPIO commands to the GPIO pin, so we have to include the RPi library in our Python program. And also if we want to control the light of the LED, for example, we want that the light will be on for example 1 second, and after 1 second it will be off for 1 second also, again it will be on for 1 second. So in that way we can we have to import the we have to import the rpi.gpo library file. Okay, and the time library. Now in step 2 we have to set the mode of our Raspberry Pi. So there are two modes available. First one is known as board mode, and second one is known as the BCM mode. So in board mode, basically the pins are connected. So here I can show you the difference between the board mode and the BCM mode. So here, if you are connecting, if you are programming and mentioning the pin number 3, pin number 3 is according to the board, but it is actually the GPIO pin 2. Okay, and if we are using the pin number 5 to be pin number 5 according to the board, it is a pin number 5, but actually it is a GPIO pin 3. Okay, so here whether we are performing the board mode or the BCM mode, if we are programming according to the board pin number, in that case we have to set our Raspberry Pi into the board mode, and if you are performing the GPIO according to the GPIO pin number, if you are performing our program in the GPIO pin number, in that case we have to set the mode in the BCM mode. Okay, so we have to clear that whether we are performing our programming in the board mode or the BCM mode, we have to set it before start the program. Okay, now step 3 is set up the GPIO pin. Obviously for example in this figure you can see that we have connected our LED to the pin number 3, that is GPIO pin 2. Okay, pin number 3. So we have to set the pin on which we will giving or getting the input or output. Okay. Step 4 is basically set pin true and false in the loop for a given time. So here we can set the pin for whatever the time we want. For example, let we want to on our LED for 10 seconds and off for 10 seconds, and again on for 10 seconds and off for 10 seconds. So in this way we can obviously perform an infinite loop, and we will keep the instructions in such a way that LED will be on and off for 5 seconds at every 5 seconds. Okay. So let's if you have any question you can ask me, and after this video, and let's move to the practical aspects of the um, of this. Okay. Okay. So let's start the connection of LED blinking program. So for connection we need few components. So firstly I'm having the breadboard. You can see this is the breadboard. Okay, you can purchase from your local market also. There are various the size of the breadboard is the various size of the breadboard is available in the market, so you can purchase of any size. Okay, so I have taken this breadboard. Okay, and this is small breadboard. Okay, basically the size depends on the number of pins that are available here. Okay, and of course I need the Raspberry Pi. So here you can see I am having the Raspberry Pi. Okay, also I am having the LED. So here you can see I am having the LED. Okay, this is LED, and I am having two wires. Okay, uh, try to use different color of wire so that you can identify the connection easily. So here I am using male to female wire of two different colors, green and blue. Okay, now what I will do, firstly I will provide the firstly I will make the connection on the breadboard, then I will supply the power to the Raspberry Pi. The main point is here that I am using the VNC that already explained to you as a virtual network connection, and I am not using the advantage of using this VNC is that we don't need the keyboard or the mouse or the desktop separately for the connection with the Raspberry Pi. So through VNC, I will use my laptop screen or my laptop keyboard or my laptop mouse. Okay, uh, for handling this Raspberry Pi module. Okay, so let's start. So here I will take this breadboard, and first of all, as you saw that in the previous video that this is our LED. Okay, this is our LED. Let insert the LED into the breadboard. Yeah. Now the main thing is that uh, here the main thing is that this LED is having 2 points. So the point that is having the longer wire is the positive one, and the smaller is negative one. So keep in mind that. Okay. So negative. What we will do? This is basically the data line, the positive sign, the positive wire. The longer wire is the data wire from which we can we can give the instructions or the output to the LED, okay, in the form of 1 and 0, true and false. And this is simply a negative connection, the smaller one. So here, this will be connected to the ground. Okay. Now, put here simply. Okay. Okay. So here you can see that we have connected this LED to our breadboard. Okay, fine. Now, we take this wire. This is the male to female wire. Okay. So in LED, as you know that this line is having the same connection and this line is having the same connection. So you can use any of the pins that are aligned with this with this point. Okay. So here I am going to connect the ground. Okay. So this is the smaller one. Okay. So here I will put this. Okay. And this, of course I will use a resistor also. So I am having a resistor of 220 ohm. Okay. So what I will do, I will connect the one terminal of the resistor to the positive point of the LED and negative and another terminal at any point on the breadboard. Okay. Now this is connected. And what I can do, I will connect the next terminal of the resistor and I will now this is the positive connection and this is the ground connection. Okay. So this is the data line. So you can see that the instructions or the data that is coming, that is going to the LED, is basically through the resistor. So the advantage is that whenever the power supply, maybe accidentally the power supply is high, in that case the LED will be not damaged. So the this register will provide a limited limited voltage to the LED, so that the LED cannot be damaged. Okay. Now this is the ground pin and this is the GPIO connection pin, general purpose input output pin connection. Okay. So in the previous slide you have already seen that this will be connected to this Raspberry Pi ground pin, and this will be connected that is to any GPIO pin. So there are various GPIO pins that are available on this on this GPIO pin diagram. So as we know that pin number 3 is a GPIO. Okay, is a general purpose input output, that is already explained to you. Okay, so what I will do, I will connect the positive point to the third. This is pin number 1, this is pin number 2, this is pin number 3. Okay, here you can see this is pin number 1. The first inner pin is pin number 1. This is pin number 2. This is pin number 3, 4, 5, 6 up to 40. Okay. So what I will do, I will connect the our GPIO connection to this GPIO pin, that is pin number 3. Okay. So let's connect it. So I've connected green wire. I've used the green wire for the GPIO connection. So I will insert here. Yeah. So here you can see that we have connected the GPIO connection. Now this is the ground pin. So you can use any ground pin of this Raspberry Pi. So here I am going to use pin. I already know that pin number 6. Pin number 6 is an ground pin. So I will connect it to pin number 6. So here you can see pin number 1, 2, 3, 4, 1, 2, 3, 4, 5
pin number. So I have connected the LED's positive point to the GPIO pin number 3 and LED's negative point through the ground pin, that is pin number 6 of the Raspberry Pi. I have also used this resistor to control the voltage that is supplied to the to this LED. Now after making all the connections, then provide the power supply to our Raspberry Pi. Always try to follow this practice, because it may be possible that if you provided the power supply earlier before the connection, and after that you have in next connection there may be any short circuit, and our Raspberry Pi can be damaged. So now first of all, make all the connection, then give the power supply to the Raspberry Pi. Okay. So the power to provide the power supply, I am using this simply USB connector. I have connected it to to the switch. Okay, simple USB connector. This is simply a USB connector. Okay. So here I am going to give the power to this. So I will connect here. This is the power slot. Yeah, and after that I am going to on. Okay. So here you can see that in default this LED is having is blinking, as in default it is not off. In default the power is going to this LED and LED is blinking. So here my I'm going to program that LED will be on for certain time interval and it will be off for certain time interval. So let's switch to the monitor and see how this program will be written and executed. Okay, so let's start the programming. This is my desktop, laptop desktop basically. So here what I am do, first of all I will open the VNC. Okay, so this is the logo. Just click here. Okay, now this is VNC. I've already explained it in the previous video. How can we install the VNC and how can we make the connection? So again I will show you how you will establish a new connection. Okay, so for that you have to click on the file tab. Okay, and the new connection option. Okay, so it will to establish the connection with the server. Basically this laptop is acting as a client and my Raspberry Pi is acting as a server. Okay, so basically I am using this VNC for only the display, for the keyboard and the mouse for our Raspberry Pi. Okay, so to connect the VNC server we need the IP address of that of my Raspberry Pi module. So I have already shown you that how can you get the Raspberry Pi IP address. Whenever you connect the VNC with the Raspberry Pi, keep in mind that our client and our server must be connected to the same network. This is very important. And if it's not connected to the same network, it will be our client and server will be not connected at all. So, for example, I am a router in my house, in my home. So, I will use my router for the IP for the connection of Raspberry Pi as well as my laptop. Okay. So, the IP address that how can we get the IP address of my Raspberry Pi? So, initially, when we install the OS in the Raspberry Pi, SD card, the SD card that we have inserted into the Raspberry Pi, we initially when we configure on the desktop that is connected externally to our Raspberry Pi, we noted down the IP address of our Raspberry Pi. So at the initial level, you can get the IP address of the Raspberry Pi whenever you first configure your Raspberry Pi. Okay. So I've already shown you how to get the IP address of the Raspberry Pi in the previous videos. Okay. So my IP was 192. I've noted down it dot 168.1.190. Okay, this was my IP of Raspberry Pi, and maybe your IP will be different. Okay, so don't write this IP. You use or your own IP. Okay. Now friendly identifier. So I will name it for example RASP. Sorry, RASP REST. Okay. Now okay. Now here you can see the icon has been created. Just click here 2 times. Now it is establishing the connection. Connection has been established between our laptop as a client and Raspberry Pi as a server. Now to log in into the Raspberry Pi, initially at the time of configuration we have set the username and password. So I have noted down the username and password. So I am going to insert it. So the username was I think it was Sheesh, and password is. So whenever you initially configure your Raspberry Pi, you must note down 3 things. First is the IP address of the Raspberry Pi, the username and the password. Okay. Now click OK. Connecting. Yeah. So here we have established the connection with the Raspberry Pi, and the desktop of the Raspberry Pi has been appeared in my laptop. Okay. So this is the initial desktop that we already got whenever we connected our Raspberry Pi to the separate monitor. Okay. Now this is the here you can see the IP address of my Raspberry Pi. So here you can see the IP address is 192.168.1.190. Okay, and Ethernet link is 0 because we have not connected to the Ethernet. Okay, so how we program? So I will use, of course, I have already told you that I will use Python for the programming of LED blinking. Okay, so whatever the program that we will write in our Raspberry Pi, I will use Python for that. Okay, so to start, how can we start? So here you can see the sign of the Raspberry. Okay, click here. After clicking, you will get the first tab, that is programming. Okay, click here, and after that Genie and Python ID is available here. So I will click the Python ID. Click here. After clicking, you will get a new window. So this is the window that it appears. So here we will if there is written something, then in that case we will click new here. Otherwise it is already created a new file. Python ID is created a new file. So I will start the programming. So to write the program, first of all I will import the library of the RPi GPIO, because we are using the general purpose input output pins for getting and sending the output signal to our LED. Okay, so for importing the library, we use the statement import. Okay, so here you can see always this Python is case sensitive, so you have to take care that for example if we write I as a capital I, in that case you can see the color has been not changed. That means we have given a wrong syntax. Okay, so I will use small. So import is used for importing the libraries of the Python. Okay, so what library I am going to insert? I will going to insert RPi dot GPIO GPIO as GPIO. Sorry. So I have inserted the library of the rpy.gpio, and I will use this library as a GPIO only. You can rename it in any name, no problem. So I will also import the time library in my program. Okay, because I am going to operate my LED in such a way that it will be on for a certain time interval and it will be off for certain time interval. That's why I have imported time library also. Okay. Now I will write GPIO dot set mode. GPIO dot board. So what it means? It means that we are setting our Raspberry Pi board as a Raspberry Pi kit or module as a board pins, not the GPIO pin numbering. We are using it for as a board pin numbering. Okay, for example, pin number 3 of the board of Raspberry Pi is the GPIO 2. So if I am using the BSM mode, in that case I will use as a GPIO pin number 2, and if you are using in a board mode, in that case I will use pin number 3. Okay. So we have set the mode of the Raspberry Pi. Now GPIO dot setup 3 dot GPIO dot out. So what I have done here, I have set the pin number 3, that is GPIO, that is general purpose input output pin, as an output only, because we will give the instruction to our LED that it will be on for certain time interval, off for certain time interval. So we are giving out command to our LED. That's why we have set it as an GPIO dot out. Pin number 3 as in GPIO out. Okay. Now we will run a while loop. While true, because we will always on the loop until unless we stop the program. Means our LED will be high for certain time interval, low for certain time interval, then again high for certain time interval, and again low for certain time interval, and it will be goes on until and unless we stop the program. So it will be going in infinite loop. Okay. So here I will use GPIO dot output 3 dot true. Okay. What it means that it will be true means 1 means on, 3 will be on for what time interval? Time dot sleep. For example, let I have using 10 milliseconds. So time dot sleep 10. That means that we are going to on the LED for 10 milliseconds. Okay. And in the same way we will off our pin number 3, that is LED obviously, for the 10 millisecond off. Okay, so I will just copy it. Okay, so here I will write false. Okay, false means it will be off for 10 milliseconds. And please make sure that after writing the while true, you should provide some gap. So automatically it will take the a gap. If it is not in that case, you will use the tab button for giving the certain gap that is here we are giving. Okay. So program has been over. We have inserted the RPi library and the time library. We have set the mode, and we have set the GPIO pin number 3 as an output pin. We will on for 10 milliseconds and we will off for 10 milliseconds. That is over. Now we have to save it. Okay. So for save, so I will going to save it on my desktop. So I will name the file. For example, I am keeping the name LED blink. Okay. Okay. So program has been saved properly. Now I am going to run it. So click here to run. Okay. Program is running, and there is a warning, so you can ignore the warning. So let's see on the so let's see whether our LED is blinking properly or not. Okay. So here you can see our LED is blinking for 10 seconds, and it is off for 10 seconds also. So see, it is blinking. It will be blink for 10 milliseconds. Okay. Now for 10 seconds, and now it is off, and it will be off for 10 seconds. Not millisecond, just second basically. Yeah. So here you can see our LED is blinking for 10 seconds and it is off for 10 seconds. Okay. So you can increase or decrease the time duration. Okay. For example, you can decrease it by 5 seconds only, no problem. Okay. You can keep this off for a long time. You can keep it on for a long time, and you can off it for a small time also. So you can whatever you want, you can provide. You can just change the time slip here, and it will be on off for. Okay. Okay. Thank you.